Yo, what's up? What's up? Happy Friday. What's up, Derek? What's up, CodaCube? Still exactly 15 minutes after I schedule my vids, bro. If you schedule your videos the same time every day, and I start streaming the same time every day, it's gonna be the same every day. I could ask you the same thing. Okay, so we're in the middle of, or we actually finished we finished an issue yesterday, which unfortunately has a bug, or we don't calculate the normals entirely correct when we slice a mesh. Tried to get to the bottom of it yesterday, couldn't. Hopefully we will manage today. It shouldn't take too much time. And while debugging this yesterday, I also noticed something else that was quite weird, which I hope we can get to the bottom of as well. And it's basically this. So when we convert a dynamic mesh to a mesh, we loop through all of the vertices and we remove the duplicates. And the way we do this is we create a dictionary like this, vertex index. We fill a list and we fill this dictionary. So, and then we fetch vertices by using them as keys, basically, or create triangles by getting the indices that way. And this works, except for we don't get the normal. But if we remove this, we get an out of bounds issue, and I don't know why. Like nothing in the way I implemented this should lead to that, even though we remove the uniqueness. Because every time we add a vertex, we set the index of the vertex like this, and then we add it to vertices. So a vertex index should never, ever be more or greater than vertices count. It should always be one less, actually. Yo, what's up, Quincy? The Friday seems to be a happy one. Sure as hell hope so. Cheers. Because I think this is the only place we add. We clear it here. Although I wonder. Could it be Or actually, this index, we don't care about this one at all. Not currently, but if we remove this one, we're gonna have to. Is the index wrong here? I don't think so. 12 vertices, 11 index at most. What do we have here? 8. No, what is it? 24 vertices, 23. That's correct. CodeCube, isn't there a mesh filter? The mesh filter... There is a mesh filter recalculation method. We tried it yesterday and it gives the correct result, but we don't want to rely on that one because we're going to do a lot more stuff in dynamic mesh, and we want to make sure that the normals are okay in the dynamic mesh, not only when we convert it to a mesh. CodeCube for operations that you need normals for. Yeah, exactly. So for instance, when we convert parts of the mesh to polygons, then we're going to need proper normals. And in the future, we're going to need it for a lot more. Okay, what I'm gonna do now, we're gonna do some testing. I need more data if I'm gonna be able to solve this. We are gonna comment this. We're gonna change these to vertices. We're gonna remove these like we did yesterday. And we're gonna change this to index like this. And we know that if we slice it, we get an error here. We try to fetch vertex number 84, but we only have 84 vertices, so index 84 is out of bounds. But if we do exactly this, but we don't slice, so we don't slice, we just generate. I want to make sure that everything up to the first slice is done properly. Okay, so up to the first slice, this works. CodeCube, do you want smooth or hard shading for the meshes? That depends on that is going to depend on how, like, various parts of the mesh eventually. So for instance, for this model, we would like smooth shading up here and hard shading for these, right? But we have done some nice experimentation with the cell shader and got it figured out, so that's not a problem. But I imagine you think about the when to have double normals and not. And by double normals, I mean just a vertex, two vertices occupying the same position but with different normals. Pretty much this, like when we generate a cube. But okay, let's see here. So this works, that's good to know. So we know it starts to break when we implement the slicing. So the slicing is where everything goes wrong. And mesh parser slicer tester. CodeCube, no, I was just thinking that after every step executed, you would run your own recalculate normals method. Yeah, I mean, like, that would work, but I would much rather just find the issue, you know? So we don't need to do it. Okay, we call slice remove. Here we call clear. We clear vertices, clear triangles, and clear triangles per edge. Then we call slice, we get keep, and that's just what we add. So let's say that it's positive. We create a new dynamic mesh. Do this for each triangle. Add triangle and vertices. It has to be some... Oh, could it be? Could it be? It probably has to do with the added vertices. So the vertices in slice vertices, so we create a cap out of these. And these are, like, if we only compare position and UV, these are duplicated from whatever we have in positive already. So it's probably here. And then they don't... Let me just double check this. We do override normal. Yeah, what's up, PG King? Happy Friday, happy Friday. Vertices altered. We add a new vertex. So we create new vertices here where we take the vertex position, vertex UV and vertex index. But then we override the normal. Or CubeMyCat says, I'm not gonna try to make that sound, but say hello from me. It has to be this one. Triangulate from center. I think add triangles, add yes. We add vertices. I think everything is okay up to... Yes. So, okay, the problem we get here then is... But fuck, we shouldn't get it. So we add the same vertex here for these vertices, but they are gonna be they are gonna have another index eventually. But then when we add vertices here, we change that index, right? This is the only... Is this the only place where we set index of a vertex inside of here at least? Yo, what's up, Geralt? Good morning, and happy Friday. Yeah, it's gonna be fun to find out why this is happening. I really want to know. Like, what would make a vertex have an index that is greater than the number of vertices? Could it be... Okay, you know what? Let's try one more thing. I want to see what happens if we do dynamic mesh. Where do we have the slice? Let's not add the this one and see what we get. So we don't, when we slice a mesh, we don't add the cap, yet then we get the same issue as well. That's very good to know. So it's not this that is the problem. It's somewhere here. Add triangle, add vertices. Oh, could it be? Okay, then I want to know, is it when we're slicing a triangle, or is it we get the same problem? It's just a full triangle. Okay. But we want to do this one as well. Okay. What? Vertices, new. Triangles, new. Could it be? Fuck, have I fucked up with clear? Capacity, but count is still 0. I want to see what happens if we do One sec. Okay, back. Let's see. Now we get the same issue with this. Okay, that's good to know. I'm gonna keep them as new now anyway. Okay, so it's not the clear. The vertices for these triangles are like we pretty much want to reset them because we take them from one mesh to another. But when we add them here, or we add them here, we re-add the vertices and we change the vertex index. Now it has to be here. It gets fucked. Add vertices true by default. Triangle in triangles should refer to this one. Add a triangle, add vertices. We could have a case where we have triangle is not valid, but I don't think so. Then we add it. Then we go through each edge in triangle. And then if add vertices is true, which it is, we go through each vertex in the triangle. Get vertices v1, v2, v3. And we call add vertex. And when we add vertex, we take the vertex and we change the index. Like I did try this yesterday, right? I want to see if we vertices add. Same issue. Yeah, okay, I know. Fuck, I'm stupid. Okay, here we have it. Vertex struct. So when we change this vertex, the triangle reference to that vertex is not changed. Fucking hell. Okay. That's why we get this issue. Okay, good to know. I just want to double check, so this is the reason. So we're gonna do... So I guess we want to do... Yeah, I don't even know how we would do this one. Now we need to do it by dictionary like this. Fuck, I really want to remove the index from the vertex themselves. I think it just makes it way more complicated, especially like here. Okay, but I'm happy that we got to the root of this one. So now I know that this has nothing to do with the issue we get eventually. Oh, what did I fuck up now? Yo, what's up, Aland? Yeah. Ooh, that is... Wow, what a slice. That is... It barely made it. Barely, barely. But okay. So back to this issue now, with the normals. So the sliced part, so this one right here, it gets the wrong normal calculations for some reason. Don't know when it happens. We're gonna double check first by doing... I want to do normalized. So we're just gonna try... Before we make it into a mesh, we go through every normal and we normalize them as well. Just to make sure it's not a normalization issue. Where do we have the slice? Okay, this time around we have the slice like this, okay. And we can see here it should be way lighter here, so it's not a normalization issue. Elon, just notice you're using unit 6 now. Yes, for all of 25, I think. If I recall correctly, we started off 25 by migrating the project. Yo, good morning, Harukanan. Okay, so It's only on the sliced one. It's not because of normalization. I wonder. I quickly thought about it here. It made sense, but yeah, of course. If we have it like this, do we get the correct? Let's stay here 1 sec. I need to... So the positive one, that's the one on the positive side of the plane. So on the same side as the normal. So then we want the normal to be negative plane normal. Yes. So it was correct initially. Alan, you face no problem when switch to Unity 6. Nah, I think render... okay, I thought we changed it. This was how it initially was, but this is wrong, isn't it? Yeah, this is wrong. So we actually want it to be like this. I think. We're gonna double check this one. I think the biggest difference was when converting to or migrating to Unity 6 was the new render feature pipeline, render graph or whatever it's called. Yeah, that I noticed. Fuck yeah, I'm pretty sure this is how we want to do it. But then it gets cold for the norm because the normal is in the wrong direction. So the winding direction needs to be changed here. But why is that? Triangulate from center. So we had the inverted normals. We had the wrong normals and the wrong wind direction. Triangulate from center. We need to go the other way here. Fuck. This is how I want to do it. I want to go 0, 1, 2, 0, 2, 3, 0, 3, 4, and so on. So this sort here is where it all goes wrong. Just to make sure, I guess we could do... There we go. Beautiful, but... Okay, so I wonder... First of all, this one. That was a very bad mistake from me. I should have made this correct in the... initially. Would have saved so much time. So the idea is... let's draw it real quick. Because I want to make sure... I want to understand... why we want to do the inverted normal on the sort. We know that it solved the issue, but I'm not entirely sure why. So let's say that we have a cube like this. It's 3D, but I'm just drawing a 2D right now. We slice it like this. We slice it so this... Let's say that this plane has a normal like this. That means that this part right here... Let's do it like this. The green part is the positive part because it's on the positive side of the plane. The red part is the negative part of the cube because it's on the negative side of the plane. Then when we create the normal when we create the cap we add here, when we create the normal here, of course we want to take the negative plane normal as the normal for this cap. Previously it was the positive, so the plane normal, which means that we get the wrong direction of them. Okay, but now we take this one, and that's what we use later on when we sort it. So let's get to the sort one, this one right here. Elon, before yesterday you said you may watch Murder Drones. I wonder, have you watched the show yet? No, unfortunately not. We'll hopefully get some time this weekend, so ask me after the weekend. I don't have nearly as much free time as I would like. Okay, sort here. We take V1 position and V2 position and center vertex. So we calculate two vertices that goes out from the center towards the vertices. Then we get the signed angle by comparing V1 center and compare, which is just forward. And it's this one that makes the whole difference. Why though? Oh, could it be? I want to know. So the greater the value, yeah, so the greater the value, yeah, so I guess we just want to do it like this, right? One sec. Like, we want a smaller value to be... We sort it on great. Yeah, maybe we could also do... I guess, so we go from minus 360 to 0. Fuck, could we do it like this? No, probably not. Yo, what's up, Omar? Happy Friday. Happy Friday. Okay, but okay. So we calculate the signed angle and then we take the, like, we put the greatest ones first. And that's why we get it the opposite way. Unless we do minus normal here. Yeah. Hopefully that is clear enough for future me to properly understand it. Okay, I think we had one, or we had another problem with the normals. We're gonna double check it soon. I just want to make sure. This seems to be working great. Beautiful. Let's jump back to the main scene and play it. Oh yeah, it takes a long time now. CodeCube passing it on to Future Me, the best solution. Hell yeah, it is. Future Me hates it though, but what you gonna do? I think the normals looks okay this time around, I said, but it still looks a little bit like shit. Why did we get this one? That's extremely weird. And this one, actually. Fuck me. Yeah, we get the result we get here because we haven't fixed the color normals yet. But for this one, it looks good, I think. Okay, I think it looks great here. We're gonna fix the flipping here eventually. Yeah. Okay, I think this looks great, apart from the fact that we don't get any eyes spawned on this one, because for some reason these are not the same, or all of these triangles don't belong to the same polygon for some damn reason. Hopefully we will get to the bottom of it soon enough. Oh, here we actually got two nice eyes. And I wonder what happened here. Why do we spawn this one again? This one should not be spawnable. Omar, I wish I knew coding. It's never too late to learn. Wonder why we get... Like, this one should not be able to spawn. Or actually, yes. I think I know. I fucked it up by definition. Where do we have it? Here, dynamic mesh threshold. If we go to 10 here, we should not be seeing eyes like that anymore. So when we create the polygons from the mesh, we do it by flood filling to neighbor. So we like group vertices based on normals and stuff like that. Ooh, this one I'm a little bit worried about. This one looks good. Okay, so now we don't have that problem anymore. Okay, great. But the problem of not spawning ice on this is still here. So what is it that makes our algorithm, our flood fill algorithm, like when we flood fill on this one right here, all triangles within this area should be one polygon, right? But for some reason it's not. Omar, but the only way I can support you is by giving a heart and a comment. I appreciate it, man. Have a great rest of your Friday. And a great weekend, actually. Let's take a look at it again. The flood fill, or basically the method we want to analyze now is called get random polygon on mesh. And get polygons. But maybe it makes sense. Maybe it makes sense because wondering if the UVs are different. No, they are not. Get polygons. Let's double check this one. We rely heavily on triangles per edge here, and that's what I'm getting at. I'm wondering if triangles per edge is not properly set up when we generate this one as a dynamic mesh for some reason. That has to be it. And triangles per edge, every time we add a triangle, which we do often, we check here for edge in triangle get edges. If triangles per edge contains the key, if it doesn't, then we add a new empty list. Otherwise, and then whatever we get here, we add a triangle to that edge. An edge keys hash code is, yeah, we flip it like this. Does this should help us. I get the feeling that this or this. Yeah, it's this fucking index here, right? Again, this index comes back over and over and over. Yo, what's up, Scafer? Have you fixed the hashcode problem? Yeah, the hashcode problem we had a few days ago should be fixed. It was a misunderstanding from me, mainly, that, like, I've always assumed that hashcodes needs to be unique, but they don't. They don't. Okay, I'm thinking about removing the index here. The problem is, like, I want an edge. I want two edges to be equal, even though V1 is like, even though V1 and V2 are flipped, if you know what I mean. So I want an edge, I want an edge that goes in this direction to be equal to an edge that goes in this direction if they use the same vertices. Vertices are decided by position and normal. We're basically developing a modeling software here. It feels like. But I don't want to do it by index like this, so I don't want to flip them like this. So how can we generate a hash code here that is the same independent of the order of these? Shouldn't we be able to do... how to generate a hash code from... And let's see if it figures this one out. Scale for half edge, exactly. Are you making a competing 3D edit to Freya Almere one? No, I wouldn't dare. I wouldn't dare. Yeah, okay, we're just gonna do it as XOR. Exactly. Commutative hash. Fuck yeah, we're just gonna do a XOR. What a stupid way this is. So v1 dot get hash code, v2 get hash code. 8room hashcode.combine. Hashcode combine C#. Is this independent of order? No clue, honestly. Yeah, that was one. That was like, we need it to be commutative hash function, so this should be equal. I wonder if combine. Yeah, like we use combine previously. I just don't know if it's commutative. And here they do hash style combination sorted pairs. So if ChatGPT does it like this. I don't care about strongest. So yeah, this should work. Yeah, okay, so that's why we can't use it. So this is just how I think. We used hashcode combine previously. I assumed that it was not commutative, so order did matter. For the edges, we don't want order to matter. So we get this instead. Okay, let's see if this is the cause of the issue. I'm not entirely sure. Let's try. Nah, still looks pretty shit. Okay, so this is not the reason for it. Okay, that's good to know. Fuck, do we have... Okay. Equals here, is this one correct? This should be true, or this should be true. Yeah, I'm pretty sure. CodeCube, good luck with the with that. Hopefully it wasn't too bad. With the cat throwing up, that is. This is the only reason I can think. If we go to vertices, position, normal, UV. Do they have the same UV? Hmm. Basically, it's like this one, triangles per edge. This one, this is like the most important part, I would say. And that's why I think this is the cause of it. Maybe we should use our old test classes like mesh parser visualizer. Yeah, maybe we should. I wonder what would happen if we do. Yeah, let's do it. Can we do it like this? Can we experiment scene? Can we play? So we get this one, and then we take add. Add. Okay, does it work? And then we don't show these, but we show unique edges. Yep. Yeah. Fuck me. And here we can see that we get the wrong unique edges. Show polygon triangles. Fuck, is this the... that's number 1. We can choose which one. Let's go 10. Unique edges is definitely wrong. Polygon boundary. Yeah, we can see here that every new... So here it works. This one is... We didn't change this one at all. This one works. This one works. But every side that has gotten new vertices are sorta fucked, right? So, okay. I think unique edges is the best visualizer of this. So basically a unique edge is an edge that is only used by one triangle. And it's extremely weird that we don't get these. The fuck? And this one. Atrium, what is the problem you're trying to solve? Sorry, I just saw it now. So this is the problem I'm trying to solve. We have a script that takes a mesh and splits it up into polygons, and it does it based on like it tries to group triangles together based on some rules. The easiest rules would be that every triangle that share edges and have the same normal should be joined, so it's just one polygon. And this works. If we take any mesh and run our script on it, we get the correct result. This time, however, we have built the mesh ourselves in a script and we get the wrong result. So something when we're building the mesh is the problem. And why are the console outputs in 2 lines instead of 1? What a waste of valuable space. That one I cannot answer. Yeah, fun. I thought it was, yeah. So we can double check here. Unique edges. Show unique edges. All we do here is we get the edges from mesh parser triangles per edge, where the value count is just 1. So where the list of triangles that share this edge is just 1. And then we draw those. So that means that triangles that share edges don't get... Like, we don't build this list in the correct way. CodeCube, just finished cleaning. Welcome back. I don't think you missed that much, honestly. Sorry, just hit my microphone as well. More than I think we have concluded, or I have concluded, that this is most likely the problem. Scafer, by the way, interesting behavior observed in Godot 4. If you don't remake your multi-mesh that is used for instancing and set new instance transforms to the old mesh, you will need to wait a couple of frames before it updates. Otherwise, instances spawn in the wrong place for those couple of frames for some reason, I don't know. Okay, like some sort of caching that doesn't update every frame. It sounds very similar to the problems you usually get when trying to change transforms on objects that are physics controlled, if you know what I mean. But okay. Triangles per edge. When we slice our mesh, so this works. Let's see here. Where do we have it? So when we take the vertices like this and do add triangle, and we fill it up like this, it works. Edge, why are the edges different? Scafer, I have no idea why it happens. I just said that it reminds me of some problem similar to that. I know too little about Godot to pinpoint it, but hope you find the cause of it and enjoy getting your hair cut. And thank you for stopping by, and have a great weekend. So, why? You know what? Since this works, this fills out this one in the correct way. But when we create the mesh ourselves, it doesn't. That makes me think that this is actually a-okay. Like the hash code for edge and the equal for edge are... There's nothing wrong with the implementation there. Instead, what I think it is, or what it has to be, or like I still think this one fails, but I don't think it fails because of the edge hash code or equals. I think it fails because of the vertex, not hash code and equals implementations, but One sec. But how we create the vertices, so we have a little bit of a different in some of these. I'm wondering, or I'm starting to think if it could be a floating point issue. So maybe we have two vertices with roughly the same position and roughly the same normal and roughly the same UVs, but there's a tiny difference. So that's one theory. I don't believe in it that strong right now. I don't have a better theory though. Yeah, what's up, Godly Gaming? Welcome to Twitch. Or to my Twitch channel, that is. We also know that we only get problems. We only get problems in fact, this is probably the key. So we don't get problems with triangles that goes through here. But we do get problems with triangles that goes through here. So triangles we slice. Like, once again, it's not only the cap. So it's not only the fill slice hole, it's actually the other sides as well, isn't it? Let's double check. Test, parse visualizer, show unique edges. So this one is sliced. This one is... So like, what I'm getting at is, like, this is the cap, and this is just a side that wasn't sliced previously. So it seems to be an issue with this. Could it be this one? Whoa, what the fuck? Where? Oh yeah, this was edge. Lerp vertex. Yeah, it's a rounding. It's a rounding point error, isn't it? Pretty fucking sure. Let's see. We want to compare. We don't have any Nice comparison with error. Right, no, compare. Are we gonna have to do extension, vector extensions, max components to vector 4? Godly gaming. So what sound are we talking about? Your cat enjoys something like that, or fun to hear. Fun to hear. Are we gonna have to do a static vector 3 compare? Yeah, I just want to do a compare. Compare rough. We're just gonna call it compare. How do we want to compare these? We want to compare them like... return. Do we really want to compare it like this? Math F. Approximate. Thank you, Atrum. Appreciate it. That's approximately. That was exactly what I was about to search for. v1.x. Because do we have approximately with vectors? Do we? No, it's just float. Okay, great. Not great, but that was what we were gonna do anyway. So we do it like this, and Y and Z. Like that, right? Atrum might just have extensions for all the vectors. Yeah, that's probably where we're gonna end up here as well. So then we're gonna have to do 3 compare. Fuck it, let's call it approximately. And can we do... Because we can't do... Okay, we can. This approximately V, but then we get position approximately V dot position, and this is how we want to do it, right? And then we change this one and this one to normal. And then we need to do a UV as well. That's okay. Something like that. Godly Gaming, the emotes are being shown for me. They are pretty. Yeah, let's do it. I think this is what we want to do. So approximately V. Can we do it like this? Equals approximately. Okay, works so far. That's a good sign, I suppose. And then we do visualizer, and then we show unique edges, and we still it's a better result, isn't it? Or maybe it isn't. Yeah. Could it be that this one... Oh, whoa, 1 sec. Yes. We probably want to do... Yeah, we do equals here. Fuck. Yeah, what's up, Cooler SK? 5 stream streak, appreciate it. I think it's a little bit better, but maybe, just maybe. Do we have... No. Okay. Godly Gaming, 1 minute and 30 seconds of ads is crazy, bro. You're gonna have to blame it on Twitch. Yeah. I just, like, I have the minimum amount of ads to disable the entry ads, you know? So when you open up a stream, ads play instantly. I don't want those. So that means that I need to have a minimum amount of ads per hour. Otherwise they will... Pre-rolls. Pre-rolls is the word I'm looking for. Mathf.com. Let's do return mathf.abs v1.position dot x minus v dot x is less than or equal to... I'm gonna do 0, 1 here. So I want a big... I just want to make sure. that this is not the reason. Because if I remember correctly, I think this one uses epsilon, which is 10 to the power of -6 or whatever it is. E6. So let's do 0.01. Cooler SK, only the OG gang will remember when this was a grass stream. Yeah, that's Throwback Friday. We will probably revisit grass soon enough. Show unique edges. What the fuck? What? How does this make... okay, I get it. Ooh, I probably get it. But look at this, okay. So this is the result I want, except for this line right here. Wesley, I remember before it was grass, just gray planes and the squares weren't lining up. That's fucking nightmare fuel. Now we are working with gray boxes instead, and lines are not lining up. It's not that different. Okay, something tells me here that it's not the epsilon that's the issue. What the fuck is this? Let's try it again. This makes no sense. I'm trying to get some data from this. Show unique edges. Now it looks worse, right? Yo, what's up, Spires? Thank you for the raid, appreciate it. Happy Friday, happy Friday. SK, Rock has banished the grey wasteland from the lore. Hell yeah, it's the brown wasteland these days. Wesley 9, the smaller numbers and floats aren't the most reliable. Yeah, but now we're doing it with a 0.01. Should be a-okay. I don't think this is a floating point issue anymore. I don't think this is a floating point issue at all. Mesh parser visualizer, unique edges. Sometimes we get... like, what the hell is this? Why aren't this... Okay, so this edge we get rid of. But this edge is left. This edge we get rid of. And then we have this edge left as well. I have no idea where we get this from, but... okay, I guess that removes this as a proper cause for it, or probable cause for it, I mean. But you know what? I take it back. I take it back. We do hash codes on approximate, like if we have two vertices with roughly the same, like floating point issue difference in position, do we get the same hash code? Ayland, what result are you expecting out of this? let's just summarize it as I want to remove redundant edges, or I don't want to mark redundant edges. We can't remove edges, then it all falls together. But I don't want to draw the redundant edges, i.e. this one right here. All of these triangles, we want to get, like, all of these triangles, they share normals, so, and they should share some of these edges, but they don't. They share normals and they share all of these edges. So all of these edges that are shared, or that has a triangle, more than one triangle paired to it, we should not draw those. But for some reason we do. And fuck, now I'm wondering, hash code here. It's probably because the hash codes are different, right? So maybe they differ. I.e. when we do get edges contains key edge, and we check the hash value, we get v1 hash code and v2 hash code, which just combines position, normal, and UV, but there's a small difference between them, so they don't generate the same hash code, and we're fucked. So yeah, using floating points values for hash codes. So exactly like you say, Wesley, smaller numbers and floats aren't the most reliable. So maybe, just maybe, this is sort of stupid here. Unless we can round it. Or truncate it. Fuck it. Let's try it. Vector extensions, we are gonna do public static vector 3 truncate. Oh yeah. What is it? 1e6 maybe. Let's double check. -6, I mean. What is it we want to do then? We want to do v dot. Like, this is going to be costly as hell. Let's just see if this works. Divided by, or I mean, epsilon. Mathf dot round to int times epsilon. Okay, float epsilon is equal to 0.0001. Let's start here. Can we actually do f Ah, there we go. Okay, round to int vx divided by epsilon and number times epsilon. This is the correct way to truncate, right? Y z. And then we want to do the same, but vector. But vector 2. We're going to change this epsilon eventually. So then what I wonder if we can do combine dot truncate. Whoops. Visualizer. Yes, there we go. Okay. I'm not entirely sure I want to do these calculations every time we do get hash code for a vertex. Re-implement with more optimized. Okay. So previously we had, so that's like one of the main reasons we had index. When we created these based on index, it was much easier. But now we have a bit more, like previously we only parsed a mesh. So we took a Unity Engine mesh, converted it into a dynamic mesh and parsed it. And like the vertices we began with are the vertices we're going to end with. So we didn't need to add or remove vertices all the time. This time around, however, we add and remove vertices a lot, which means that we can't rely as heavily on index because we add and remove vertices. I guess we could rely on indices, but every time we add or remove a vertex, we're going to have to go through the full vertex list, go through each vertex and manually change the index, and so on, which means that then we could just as well do this. But I guess truncate will work for now. And this, okay, I like this a lot. Let's see how it looks with our creatures this time around. Doesn't look too good, honestly. We still seem to have some issues, I would say. Atrium instead of optimization, multi-thread. We're definitely gonna multi-thread this shit. So that is definitely true. It still doesn't seem to be working properly. We tried to spawn... I'm gonna pause this one. We're gonna remove these. And we're gonna add mesh parser visualizer, show unique edges. Yeah, look at this. It's still... Oh, that's still hella bad. Okay. One thing I'm gonna do also is... mesh parser visualizer. We're gonna remove the bugs here. And then I want to see what happens if we do vertex extension. Let's change this one to 4. That took its time, which makes me want to like, I wonder if it works this time around. Is this a... This is an icosphere, right? But this isn't. Look at this. It roughly works. We still have this issue. How? Why? 0.0001. We shouldn't be getting this issue, right? Weird. And then we only get 1/3 hit rate, pretty much. That's not that good. We stop after 10 tries, that's true. But I would really have hoped that we would have gotten more ice. Yeah, here we have an issue as well. Like... Really? Makes me want to try... one sec. One sec. Yeah, it feels a little bit risky to rely on vertices. Like, when we are down at 0.001, it's a little bit too close together. The risk is that we emerge vertices that we should not merge. But this looks to be Okay, this one is correct, I would say. This... I have no complaints about this one. Or do I? No, I don't. Okay, that's beautiful. And then we have this one. How many eyes do we have on this one? 7 eyes. It's not too good. Yeah, it takes so much longer. It feels like when we do triple truncate for each hash compare. It's rough. We are gonna... I want to visualize this one as well, just make sure that it is correct. Show unique edges. Yeah, looks correct to me. Okay, beautiful. I'm just gonna run, grab a cup of coffee, so give me a couple of secs. Okay, back, sorry. Okay, let's add a couple of more monsters. This is gonna take an extremely long time, but I want to see what we have. And if we can't use index, what can we use instead? Did I fuck up the rounding? Where do we have... Where's my rounding? Subdivide rounding. Triangle subdivide rounding. There we go. Yeah, it's this one I removed, right? Yeah. I mean, even if we do this on a secondary thread, which we eventually are gonna do, still hell of a long time. I want to test this one as well. So this one is a little bit weirder because here we start with an icosphere and then we slice it a couple of times. Yeah, a bit too slow, a tiny bit. I want to see what happens if we do mesh parse visualizer on this one and we do show unique edge. Oof. Whoa, 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 this is good. Holy shit, this is good. Wow. That's honestly way better than I anticipated. But if we show polygon boundary instead, show polygon edges maybe. Do we even have any? Yeah, and we do 10 maybe. Doesn't this one work? -1. Oh yeah, -1. Here we go. And we don't show the vertices, we only show, yeah. So when we do the polygon, it doesn't look that good. 25, but if we do it like this is actually, this is beautiful. So for each colored part, we want to spawn eyes. Okay, this is this works better than I anticipated. Except for the it's being a bit slow then. So we can see here we don't spawn any eyes on these rounded parts here, and that's because in our Sten creature definition we group them by polygon by a threshold of 10 degrees, and there's, which means that each triangle on these rounded parts is its own polygon because it's more than 10 degrees between normals for those. Okay. It's a tiny bit too slow, but it's a start. Yeah, I think we can commit this. Oh, I do so want to simplify the mesh as well, because if we look at it, the meshes, they are pretty crazy. The way we create these caps is yeah, it's not too optimized. But we will get to it eventually. Like, you could probably lower the polygon and vertex count on this one quite a lot. Atrium, well, the trick is just to have a generation animation and thread it all. Then it's like they grow. Yeah, definitely. So like the idea is to do something similar, but even though we pass it off to a secondary thread, I don't want it to take too long. Like, we will probably not have any creature spawn on screen. So it's going to be like this. If if a new creature comes to visit your garden, it's going to be walking in from the side, from the forest. So we just spawn it outside of the map, do it on a secondary thread, the player knows nothing, and then it just walks in, right? Or if you breed to creatures, you're not gonna see the child instantly, you're gonna see it the next day. So whenever the player goes to sleep, you can just pass it off then. Or before, whenever, basically. But yeah, like, optimizing this, however, so like when we have generated the mesh and transforms it into a Unity engine mesh, then we need to optimize it, because then it's actually a mesh that is going to be rendered, skinned, bended, yeah, you know. So we can't have simple stone creatures looking like this. That's going to be way too heavy, I think. Especially, we also want to have a little bit, maybe we want to have a little bit better collider. So we want to have a simplified, worst case mesh collider. Then we also need to fix this. But yeah, we'll see where we end up. Atrum, have you checked if Unity's new auto LOD works for runtime? I have not. I doubt it, but definitely gonna check it out. Let me write that up. We're gonna use it later on for some different assets, but not at runtime. So I'm gonna have to learn how it works at some point. Yo, what's up, Jax? Happy Friday, happy Friday. Okay, so the biggest problem with the current solution is, I'm gonna remove these, is definitely the hash code generation here. Maybe even the equals, actually. How would one solve this? Atrum truncate in the constructor. That is fucking genius, man. Oh, you know what? What the fuck? Yeah, we're gonna generate the hash code at construction and just return that one. I was thinking first, like, would it actually be good to have these as truncated values? But I think I want my normals to be a little bit specific. But fuck, yeah, of course. How tired am I? We should just do... But it's a struct. Atrum, I was thinking truncating values, players won't notice anyways. And maybe true. I will notice though. But I'm also wondering, like, if we alter them, it's a struct, it's a value type. I wonder if we were to do... Well, let's call it hash code. if we were to do this, that should be okay. I want to make these, yeah. Like this would definitely make it a little bit quicker, wouldn't it? It's just an int, so it's not that much memory. We're gonna replace index. Yeah, we're gonna make these read-only values, and we're gonna do it like this. It still works like it did, right? Yep, it should. Yeah, 100%. This is 100% the solution. Okay, so I'm gonna commit this. I'm gonna commit this, and then we're gonna remove this one, and we're gonna make these read only. We're gonna tighten it up a bit. I think this is the only value we change, so it should be okay. But let's see here, in Edge, what did we do? We fixed the hash code here. We made it, what was the word for it? We're gonna commutative. Okay, so I'm just gonna commit this one real quick first. What issue was it? Yeah, it was this one. So it's closed, but it's okay. What is it? Generation dynamic mesh primitives. It's the edge. Make primitives dot edge. We're gonna call it use a commutative. Is that the correct term? Commutative. Okay, that's that one. And what do we have here? We do approximately here. I think that's still good. So we cache the hash code. Do it like this. Implemented approximately. Yep. Atrium, there's always the option of doing two vertices, one used for calculation that is a lot more optimized, and one that is for simplicity and working on. Then when you need to calculate, you convert the entire mesh into read-only mesh that is faster. Like when I need to truly optimize mesh generation, I tend to also remove Unity's Vector 2, 3 as they are incredibly slow at times. Oh, I had no idea. So basically, oh yeah, I get it. Maybe. So internally, you would work on something else. You have like working position, normal UV. And then you have a proper, more detailed position. We'll think about it. Like the whole thing is that like I anticipated this dynamic mesh to be an extremely heavy from the get-go, because we're gonna do like a lot of crazy stuff eventually. We need to calculate a lot of things and like know everything there is to know about this mesh, every relation, everything. Generally, it's the last step I do using Profiler to detect slow operations. Yeah, 100%. It's just like when it was something extremely obvious like this, like doing truncation every time we call get hash code, it just feels better to get rid of it early. But 100%. I already know a few other stuff as well, which we have just left that we keep around, and we're gonna optimize later on. But let's see here. I also want to add vertex. And for vertex, we added cache, vertex, hash code, and make equals be an approximation, maybe. And triangle, what did we do here? I don't think we did. Oh, yeah, yep. Fix winding order. And then finally we have dynamic mesh, where we did this. I wonder if we can skip, maybe we can just do change it back, I think. Elon, I'm creating art for one of my card, for one of my mod, and God, I love the mask component in Unity. You're able to add shine to stuff that looks like metal if you use that component. Mask component. Mask in Unity UI. Is this the new Unity? Unity UI? No, probably not. Are we talking about this mask component? Unity UI is the good one. So Unity UI, is it? It's the old one. UI Toolkit, yeah, that's the new one, right? I haven't tried it, so I have no idea if it's good or bad. Oh, nice. Emojis are a bit overused these days. I'm gonna have to read up on this one if I'm gonna dive into it or use Unity UI. Atrium UI Toolkit is absolute garbage. It's 7 years since release and can't do everything Unity UI can still. Oh, is that it? Are we still missing functionality in UI Toolkit? I wonder what structure. I like this though. Like when I see this, I'm intrigued. Mm. Atrium, it just goes against the component system. Yeah, so it seems like it's more like. So instead of building up your UI with a lot of components or a graph of components or a tree of components, you just add one component or what UI object, and then you have a lot of options within that. I don't know. I'm gonna have to read up on this one. Atrium, I might just be hateful, but I'm also correct. So like I have never tried this one at all. But it's gonna be time for UI eventually, and I'm gonna have to decide if I'm gonna do Unity UI, UI Toolkit, or I don't know, roll my own custom stuff. Because I have some crazy ideas for my UI. But before I take the plunge, I'm definitely gonna have to read up on this one. I know I have worked with Unity UI quite a lot. Not the biggest fan. I mean, it's okay. So I was really hoping for this one, but like, you're not the first person to tell me that it's shit. Unfortunately. Atrium, I can help you with Unity UI, so it feels amazing to work with. Biggest issue Unity UI has is handling panels. Aland, do you know Unity have its own ImGUI? ImGUI. Yeah. Jax, I remember there was an old tool called NGUI. Yeah, I imagine there's a lot of UI tools. Atrium, like how to spawn in panels, how it should handle existing panels, animations, etc. Yeah, so the thing is, like, when I'm thinking about, like, basically I want my interface in this game to be, I have this vision, or I have this concept of like a sort of a physics-based UI. So I don't know exactly how I want to implement that one. I don't know if you can get good, like, physics-dependent UI with UI Toolkit or Unity UI. Like, think buttons affected by gravity and stuff like that, but not really. We'll find out eventually. Atrium, you can do anything in Unity UI. You have to believe. Yeah. Have I disabled my highlight, by the way? Okay, but okay, this looks okay. I'm wondering why my highlight is not working. Probably because I have it disabled. We're gonna worry about that one later. But okay, so now this one is finally finished. So 3 commits after, or actually, we're gonna commit one more thing. What did we do in dynamic mesh? We did recalculate. This one we're gonna remove for now. Is empty. Slice remove. Yeah, that's about it. We added slice remove. And that's more related to this one. Add dynamic mesh dot slice remove method related to 205. Okay, nice. Now let's finally move on. Oh no, did I add it and then remove this? Whatever. So what I want to jump back to now is this one. Yeah, I think we're going to commit this one and close this issue. Because this one works, it's very simple. So what I think is next in our generative creatures implementation is to rework these modules. So right now they work on meshes. So for instance, we generate a dynamic mesh here, and then we actually return or we convert it to a Unity Engine mesh at the end. And then later on, when we're going to calculate the position, we create a new dynamic mesh and use it. But that's only a minor thing. I want to rework this module system because I want it to, like, so basically when we're generating creatures, we're going to define how a creature looks by adding a set of nodes in a specific order. So the idea is to have a start node which generates a body. So the start node takes no input but outputs a dynamic mesh. The output is going to go into, what do we have? It's going to go into some other node that maybe generates a or that does something with the dynamic mesh and outputs something else, and then we're going to have a node that takes a dynamic mesh's input and returns a original mesh or a Unity Engine mesh. I pretty much want to like extend this into a system of that sort, basically. And like best case scenario, we can then use Unity node UI or whatever it's called, so we can define creatures by nodes in the editor. That would be pretty sick. Yo, what's up, Ling Ling? Long time no see. I'm good, I'm good. How about you? So basically, let me commit and close this issue, and we're going to jump to the new issue. Generation module mesh generation. Is it in generation modules? Yeah, should be able to. What would, one sec, mesh. Oh yeah, we have this one which I don't use. There we go. Ling Ling, good to been a little busy with school. Hope everything is okay. Yo, what's up, Martin? You can't just jump in here like that. Ling Ling, I recently updated my IDE from 23 version to 25, and while I hate the UI, it's so much faster and easier to work with. And that seems a little bit... It doesn't feel like things get faster when you update them to newer versions these days. They just get slower and slower and slower. Okay. What did we... Yeah, mesh generation module. Mesh generated module. This one resolves 205. Ling Ling Martin is fucking bastard. I don't know if he is, but he definitely behaved like one. That's for sure. Where do we have? That's not the one I want. Ling Ling, I clicked it. It's spam open new window. Are you serious? Did it really? Yeah, never click on links in chat here. Like I'm doing my best. Over on YouTube we have I block links by default. Don't do it on Twitch though. Fucking hell. I always click links. What you mean? Yeah, be real careful with links. Okay. Implement creature visual variations. Fuck, maybe. Okay, we're gonna reuse this issue and make it a little bit more descriptive. We're gonna redefine this a little bit. Every creature will be procedurally generated. Procedurally, isn't this a word? Generated based on a rule set, maybe. So I'm thinking, I don't even know where to start or how to describe this. Or based on a set of rules. The rules are defined by chains or a net of nodes. A node network of generation node. Generation nodes. A rule set. Yeah, we're gonna change it to a set of rules. Let's move a step away from functional programming. Elon, but back to the UI topic. For make UI for runtime, use Unity UI, but making UI for your editor, use UI toolkit. Is that what most people agree on? So I want to draw, like, when we build this node network, I want it to look sort of like this. So for Sten, for instance, it's gonna look like then that's small. Let's go 30 maybe. Generate dynamic mesh. um, And then I'm gonna have and this is dynamic mesh as well. And then we have spawn ice. And the question is what I want to keep these as, but that it's going to be visual. What did we call it so far? We call it visual. Creature visual object. Creature visual object. And then here we might have convert to mesh. And here we then have apply creature visual object to mesh node. So the idea is that we could probably, we take this mesh, we put here, maybe we have spawn, spawn mouth. And then we have and here we also have an apply creature visual object to mesh. But the thing is, so like we're probably spawn ice here, we're gonna have some extra nodes here that takes a creature visual object and does something to it, and then so we're gonna do a node, like we're gonna build our creatures in a node-like way, like this. Shouldn't be too hard to convert what we already have to this. Okay, let's see. Ling Ling, do you do any testing for your game? We have some visual test components and stuff like that, but no automated tests yet. It's on the to-do though. Atrium, well, I still use old editor UI because it's easier to do, responsive and faster to set up, but for Unit 7 you might need to start swapping over. Can I ask you, like, what is it in Unity 7 that is going to make it preferable to swap over? Okay, but something like this. But can we write? Yeah, we can. Yeah, we're gonna draw this in Mermaid instead of having it here. Okay, but every node is gonna have a set of inputs and a set of outputs. I wonder if... Yeah, and the inputs and outputs are going to be wrapper objects that has... Wrapper objects. Atron, well, Unity has stated that they want to replace the old UI, and Unity 7 is the first time they are starting to clean up and remove all the features. That actually makes me happy to hear. Like, slim it down a bit. Slim down. Unify. What is the word I'm looking for? Like, I've been down that road when you find some package in Unity which sounds all good and stuff like that, but then you notice that it's like half implemented and it hasn't been updated in a while, and yeah. But let's see, for Unity it's a good thing to deprecate old tech, no need to maintain it, so getting used to the new one is probably a good choice for the future. Yeah, definitely sounds like it. Atron Unity since 2018 has been a mess, and I hope they're starting to fix it. Like, honestly, Unity 6 seemed and seems like a step in the right direction. I wonder how I want to handle So instead of modules, we're gonna go to nodes, I think. Yeah, so I'm gonna put a pin in it. I think this is a good point to stop. I need to run anyway, but it feels like we're starting a new chapter here, so this will be the focus of next week. Want to extend and improve on the creature visual variation implementation right here, or like the node system or the generation pipeline. But yeah, felt good to close 2 issues today, and yeah, we will start with this next week. Yes, thank you so much for watching, everybody. Appreciate it. I'm gonna send you onwards, and have a great weekend, everybody. Peace.